In Part 4 of Lecture 6, we will discuss constructing an LR0 state machine. The first thing that we need to do is to construct the states to which we transition from state 0. These transitions will depend on the symbol immediately after the dot. In this case, we are transitioning past the non-terminal expression. Yes, we don't know yet what terminals or tokens will take us past E, but let's deal with the case where we have already gotten past E. There are two items where the dot is immediately followed by E. These both appear in state 1, with the dot moved past the E. In both cases, the symbol beyond the dot is a terminal, so there are no additional items to add. Next, let's take a look at the states to which we transition based on T. There is only one item where the dot is immediately followed by the T. We now move the dot after the T, and we have in state 2 the only item, E derives T dot. While I have three separate items that have F on the right-hand side, only one has the F immediately after the dot. T derives dot F. When we transition on F, we now will have T derives F dot. Both states 2 and 3 have the dot at the end, so there will be no new additional items that need to be added to this. Now that we have created states based on transitions on non-terminals, let's start creating states based on transitions on terminals, starting with the plus sign. There is only one such item, and transitioning based on the plus sign puts the dot immediately in front of the F, standing for factor. We need both initial items for F. F derives dot identifier and F derives dot constant. State 5 looks an awful lot like state 4. The only difference is that on top you see T derives minus dot F. This shows the transition on the minus sign. Again, we need initial items for F, the same ones that we saw before. Now we add state 6. The transition is on identifier, and whereas the item in state 0 was F derives dot ID, here in state 6 it's F derives ID dot. Again, having the dot all the way at the end means that there are no additional items that need to be added. The only symbol immediately after the dot in an item in state 0 is constant. We now add a transition on constant. F derives constant dot. Since it is at the end of the item, there are no extra items needed. We now have all the states directly reached from state 0 by a single transition. As you can see in the diagram, there are dots at the end of the items in states 2 and 3. That means there are no additional transactions for these states. Let's take a look now at state 4. We have the dot before F, so transition from F takes us in this case, as you see, to state 9. Term derives plus F dot. No initial items needed. Again, it's a final item. We can't go any further. On ID, we'll again go to state 6. F derives identifier dot. And on constant, we'll go to state 7. F derives constant dot. State 5 is more or less the same as state 4, except for the minus sign instead of the dot. Again, here we have the same three transitions based on F, based on identifier and constant. State 11 will be different from state 9 in that the final item in state 9 is T derives plus F dot, whereas in state 11 it's T derives minus F dot. The transitions to identifier and constant will be exactly the same as they were for in state 4. States 6 and 7 have f derives id dot and f derives constant dot, respectively. These are both final items, the only thing in their states, making these states final states. Let's take a look at state 8. It's a different story. On t, we have a transition to state 10, e derives e dot t dot. The others all are to states that we've already seen before. On plus, we go to state 4, on minus to state 5, on id to state 6, and on constant state 7. With this accounted for, we now take a look at state 9, which is a final state, 10 a final state, 11 is a final state, and 12 is the most final state of all. This is the acceptance state. We give this the highest number for reasons that you will see shortly.